Hi, Anton.
Hello.
Hello. So, Anton is a developer advocate with us here at JetBrains in the Kotlin team. I saw in your bio you're also a Java champion. So, I guess, like me, you came to Kotlin via Java.
Exactly.
And today you will talk to us about using more idiomatic Kotlin. I guess when I first started writing Kotlin, I was basically writing Java, but in Kotlin. And then as you get more experience, you turn it more into idiomatic Kotlin. I'm sure you'll have lots of tips and tricks for us. You also
Exactly.
provided some fun. Sorry?
Exactly. Yes, that's true.
Yes. Awesome. So I'm really looking forward to that. You also provided some fun facts, and something that people might not know is you make beautiful art called Circles by Anton. And
Yes,
people can check that on Instagram. And sometimes you also post on Twitter, I think.
I do.
All right. So I guess let me add your slides to the stream. I think you have lots of content for us today, so you can get started. And then I will remove myself. Have fun.
Thank you. So, yes, we are going to talk about idiomatic Kotlin today. And as Mary said correctly, I came into Kotlin from Java. So, the content I'm presenting today is kind of through the eyes of Java developer or former Java developer. I've been programming in Java for about 20 years. And now I am a Kotlin developer advocate at JetBrains, mostly working with the Kotlin team. But actually, if you look for the YouTube content, you will probably encounter some of my presentations about the other products that we have at JetBrains, about IntelliJ, TeamCity, maybe a little bit about Kedana as well, which is the new code quality platform for all kind of languages and technologies. I live in Tallinn, Estonia, so that's a very nice view of Tallinn you can see on the screen. But without further ado, let's proceed with the Kotlin, actually. And I would like to start with this screenshot of our documentation page that lists all kind of small idioms that might be useful for you when you start programming in Kotlin and you want to learn how to implement one or another thing. When you come to Kotlin from Java, you really can program as in Kotlin as if you are programming in Java, but there are some more efficient ways to express the same things in Kotlin, and sometimes they're safer, sometimes they're more efficient even. And so there is a page we collect and add more idioms to this. I think it makes sense to say that idioms are not the design patterns, right? So they are more about some single expressions in your code, how to write or organize the code inside a function in most cases. Not necessarily, but you wouldn't attribute any of those idioms to design patterns. As a matter of fact, it's more about the style, not about structuring or some like defining a behavior like formally in your application. So Kotlin comes with a lot of syntactic sugar, and a lot of those syntax features, they are really like a syntactic sugar. So if you desugar them, you will see a proper Java code, just too much of it. So Kotlin makes it much more concise. And since Kotlin was invented as a better Java or a better JVM language, in our documentation, you will see a list of features compared to Java. If you're a Java developer and you want to see how different Kotlin is, well, you will find the list there. So my goal for the presentation today is to go over of some of those features. I have grouped them in my presentation. And for each feature that I'm talking about, I will kind of explain what kind of idioms or what kind of usefulness this feature brings. Hence, the title for the talk is Idiomatic Kotlin. So if you talk about the notion of idiomatic, like the term itself, even detached from programming, like in linguistics, it means that you're using the expressions that are natural to the native speakers. Like, for instance, if you speak English, then English is very rich in idioms, and there is like a whole book on English idioms, that the phrases that mean something else compared to what you can translate word by word. But in the context of the programming language, we think of a commonly accepted style. So there is no like a rule, or the compiler would not tell you that, hey, you should be doing it this way or that way. It's the commonly accepted style within a community of developers, and somehow Kotlin is more than 10 years old already since it started, and the community was picking up this style and developing the new not non-formal formal rules. And here we are, we now have books about the style in Kotlin, how to structure your application, how to express something in a more efficient way or safer way. And now it's time to actually talk about best practices and also the idioms. And from the other side, well, the idioms are often useful for efficient use of the language, so that you can make your programs efficient from the different points of view, from the readability point of view, from the efficiency point of view, and so on. So we start with very simple things today. I want to start with a thing that non-Kotlin developers who come from the other languages than Java don't even start thinking about. They accept it as given, but for Java developers, it's a small jump, let's say. This is something that we didn't have in Java we still don't have it, like the top level functions and especially the extension functions. So what it means today is that you can just start writing your application by using the functions and not defining any classes, right? We can call the functions, we can pass functions as parameters, because we have those top level functions and high order functions, where you can express parameters or define parameters as functional types, like in this example here, and so on. So you don't declare classes. And that's kind of a first rule of our first presentation. This was actually expressed by some of my colleagues in the past, but I came to this empirically myself. When I'm programming in Kotlin now, I don't think about classes, and I start thinking about classes only if I need to model a domain, when I need this domain model to be used in my application. Before that, if I just express the behavior, if I just need to this program to do something, then I just use functions. And until I need really to model the domain, then I start introducing the classes. So when you start programming in Kotlin after Java, and this is the first use case when you start thinking about the functions, is when you need to create utility functions for something. Like string utils is probably the most famous one. Like you had it in every Java project virtually. And when you need to express this in Kotlin after Java, you learn, I need a static function, and static functions, like static keyword, is not existing in Kotlin, and I should put my functions into a companion object. And then you kind of re-implement the same thing, the same code in Kotlin as you would have done it in Java. And then you learn further that there is a pattern, or like the idiom for static objects, like the singletons, right? In Kotlin, you declare them as objects, not as classes. And in this case, you don't need to declare a companion object to make this kind of function. But in reality, we don't need a class here. We can have just this static function. Of course, on the JVM level, we don't have functions as separate objects. You still need to be enclosed within a class. So the class name will be derived from the file name, and grouping now happens to be not on the class level, but on the file level, right? So we don't really need classes just for grouping. We need classes for actually for modeling. And moving further, making it more domain sensitive, we can start using the extension functions where we can say, okay, this type in a specific situation may have additional function. Like for the string, we may want to check if the string represents a phone number within a specific context. So that context is something that you have to actually take care of, especially if you're adding the extensions to the global classes like string or integer or something like that. And we do have features in the language for organizing this kind of scope control. But if you go and check our documentation, whether or not the extensions should be like top level functions, or we can just declare normal functions in classes, there is no rule for that. It's more like for you to, as a tool, right? You can use just functions with parameters, or you can create extensions functions. There is no strict rule for that. There is advisory that you probably want to restrict and minimize the API pollution surface. So like if you're adding an extension that is not meant to be used everywhere with any occurrence of a specific type that you're adding this extension to, then probably you want to add this extension as a member of a specific class so that it will be only visible within that specific class, or can be used only with that class where it's declared. So this is kind of about scope control. And the real life example where it's used actually is Spring. So a lot of Java developers are using Spring. A lot of Kotlin developers also are using Spring. And Spring has the Kotlin extensions in their library since Spring version 5.0. And I want to demonstrate one example that they have. So the JDBC template class that you can use for accessing the databases in Spring has been there for 15 years already, maybe even more. It's a very stable API. It provides all kind of utility functions to execute the query and get the result back. And the query function there takes 3 arguments in my example here. It actually has many overloads. And so it takes 3 parameters. The first one is the SQL query. The other one is the row mapper, basically mapping the results into some object. And then there is a variable argument list of parameters that you can supply for the query. And if you check, this is the function that is implemented in Java. So you can check the sources. This is how it's implemented. You can see the var arg is can be null actually at the very last position. And well, this is a Java API, and if we use it from Kotlin, we should be using it as is, right? But let's see how we can change it slightly. What if the role mapper was at the last position? In Java, it's not possible, but in Kotlin, it is possible to put var args at any position in the method signature. So it opens up a possibility for a little bit more transformations if we put the lambda at the very last position in the list. So first of all, we can perform the SAM conversion. So if it's a functional interface in Java, we can just declare it as a lambda. We don't need to specify the type, the interface name. And the compiler knows that, okay, we are using this lambda in the place of a functional interface, so it knows how to map this lambda to the specific interface. Further on, we can actually move the trailing lambda out of the parameters list in Kotlin. So if it's in the last position, we can just type the arguments in the braces, and then after that, we can just write the lambda outside of the braces. So let's see, if you reformat it a little bit, it looks like this. But what's the function? The original function was not with the same parameter list. The order was different, right? The Java did not allow us to put the var args on the other position than the last. So what happens here is that there is a Kotlin extension function in Spring that you can use now from Kotlin, and it just looks much more natural when you use it with Kotlin in Spring, and it's provided by framework. So it's kind of, there is a coherence between the framework and the language now, and it's making use of that extension function capabilities, right, in Kotlin. Now, so let's make a little summary here. By using functions, extensions, the ability to put the lambda outside of parentheses, the ability to put var args on a different place than the last, and with SAM conversion, the code became much shorter, easier to read, and kind of more attractive when you write it in Kotlin. Okay, let's proceed further. We talked about extension functions already. We know what they are, and if you don't, I didn't really actually explain from the beginning what the extension function is. It's the ability to add new behavior to the existing type without declaring it within that class, right? But if you need more explanation, I suggest you to check the documentation for that. But the extensions are actually everywhere in Kotlin standard library, and the brightest example of them all is actually the group of functions that we call scope functions. So scope functions, their primary functionality is to execute some block of code within a context of a specific object or a specific instance. There are 5 functions. They are different in a way that how they provide the context object and what kind of type they return, whether it's the result of the block that the function executes or the object itself on which we are executing the block of code. But the point here is they are all implemented as extension functions, or they use extension feature from Kotlin in one way or another. And here's an example of how we can actually use one of those functions called apply. So if I'm configuring the basic data source, which doesn't have any builder or anything like that, it's a class with a default constructor, and there are just a bunch of properties that we need to initialize to use this data source further. Then we create an instance, and we need to refer to that instance every time we need to initialize the property. So on every line, we are just duplicating the name of the variable. And with the apply function from the standard library, we can declare this, like instantiate the object instance. So we have basic data source instance, and then on that instance, we can use the apply function. And within the block that we supply as a parameter to that function, we have access to all the properties of that specific type of basic data source in this example. So, and the result of the apply function is the object itself mutated with the initialized properties that we have specified in the declared block. So that's very idiomatic to Kotlin, to group the initialization within the apply block. And that's a standard library function. It's an inline function. It can be used on any type. Yeah, you can see it returned this, meaning that it will return the same instance that it's being called on. And the parameter of this function is an interesting one. So it's also an extension. It's an extension to any type, but it's not a function. It's a functional type, right? It's not just a function. It's a functional type. it's actually a lambda. And this is what we call lambda with the receiver. So not just extension function, but lambda with the receiver. It may have parameters, it may have no parameters, but the point is that everything that is being executed within this block of code is actually happening within the scope of that specific object, meaning that we have this implicit this variable everywhere that we don't type out, but otherwise it would have been like this dot driver class name, this dot URL, and so on. So the lambda with the receiver is the central component or central language feature to organize this kind of expressions. Okay, the other function that we have, the other scope function that we have in the library is the let function, and combined with the save call, the question mark dot, we actually have this small idiom for checking for the null value. So if you write this code in a Java way, let's say we retrieve an order, we have an instance of that order, we have to check if it's null or not, and then we can access the properties of that specific object. In Kotlin, it's pretty idiomatic to skip declaring an extra variable and directly execute this expression like question mark dot, the save call, and call the let function to actually work with that specific object, because the let function will be executed only if the result of retrieve order function is not null. We have a save call there, and within the block for the let function, we have that object as an implicit it variable. So we can access the customer property of that order and do something with it. There is another way to express it, but it's probably a matter of taste in this specific case, like retrieve order and safely access the property and then do something with that property. So the latter example that I have here in the slide is exactly about that. But to me personally, the first example with the let function reads more naturally, maybe because I'm a Java developer. So there's more functions in the library. We are not going to go over all of them, but if you want to learn which one you would like to choose in a specific situation, then there is like this kind of a table that explains you, okay, some of the functions receive it as an implicit variable, and some of them receive this as an implicit variable, and some of them return the result of the block execution, so the very last expression in the lambda will be the result, and others return the same object that they are being executed on. That's the difference. So depending on the situation, you may need to call one or another. But let me show you one example where it's when people actually learn about those functions, they start overusing them, and sometimes they create some funny code like this. This is a real code from a real application. Maybe it was created, like the result that we see here was created after some refactoring, that they had some more logic in this function, in this expression, and then removed something because of the requirements, and this is what they ended up with. But I don't know the history of the code. But generally, you can spot that this let function here is not needed. You could have instantiated the instance of the file object, just providing the path string as a parameter to it and then calling the expression. So if they didn't use those scope functions and used just the simple, Java way, this would read better in this example. However, if you think a little bit beforehand or analyze what is happening in the first example, you would write it like this. You want to return a file and then also instantiate or actually create the directory. For me, the also function is actually the indicator that I actually want to check the logic of the function. So it's just my trick. Maybe for some others, they just use also function all the time. But I came to be kind of skeptical. If there is an also function, then I need to analyze whether or not it's actually needed. Maybe I could restructure my code a little bit to be not so idiomatic and make the life easier for my colleagues who are not that proficient with Kotlin but more proficient with Java, because reading is an important part of developers' job. Another feature that I think is really great, actually two features that you want to use in Kotlin, and there are situations in Java when you would like to have those two features in Java and you just cannot have them. The name parameters and default values. So in Java, this is kind of exactly the idiom in Java. When we need default parameters, we have to use overloading for the functions and then, or for the constructors as well. Then we can organize this kind of default value feature in Java, and we can just use that. But in Kotlin, we have default values. You can specify the default value in the signature for the parameter, and then just use this function without specifying the parameter that has a default value. And the compiler actually will tell you if the parameter is missing, if it doesn't have a default value, right? So, but here's another example. Imagine if we have 3 parameters as integers, then we have a color, and then we have some string as a description. From the first sight, it actually could guess what kind of types and what kind of variables and parameters we are initializing here, but it will be a compilation error because well, it's not clear. It's not always clear. It's not always possible to guess which parameters you are initializing by type. So it would be too much magic, probably. Probably that was the decision why they didn't make the compiler so smart to guess which parameters we are assigning in the function call. And therefore, another feature comes very useful in this place, being able to use name parameters. So we explicitly say that, hey, I'm passing this parameter into the function, not some other one. And actually, it has a very nice side effect if you are doing code review process and you're not using the IDE where you have all kind of magic hints in the editor, then explicitly written code is the same everywhere, right? If you are using some web-based system to do the code review, then you would clearly see that, okay, we are assigning, or like we are passing the color, we are passing this value to that specific parameter of this function. So in Kotlin, the default arguments is actually a very nice idiom for getting rid of the overloading, like in most cases. Not always, not 100%, but for the most cases. And to make it this feature kind of easier to use, like to be available in different situations where you need it, then named parameters are actually required. You can use name parameters without default arguments, but having default arguments without name parameters is pretty hard. It limits the ability of this feature. Okay, next one is expressions. We already seen the expression syntax in the example with the scope functions when I was creating the file and so on, but you can get to this syntax, like the expression body syntax, from the different starting point, I would say, just because we have expressions if, try, and when that are statements in Java. So let me show you an example. Here's like a very simple pseudocode, actually like a correct code in Kotlin. Imagine we are writing some game and there is a auto control engine, like auto control logic within that game, that we are adjusting the style, the driving style, depending on the weather conditions. And so if the weather is rainy, drive safely, otherwise just drive. And if we put this snippet of code into IntelliJ IDEA and pretend that we can hit Alt Enter, what will happen? First of all, we can leave the assignment out of the if expression like this, because if returns a value, we don't need to specify the return statement in each of the branches. So we can express the same thing in one expression. And since it's just the single expression, right, and we just return the result, we can actually inline the variable like this, have one single return statement and the if expression afterwards. If we proceed further, we can convert it again to the expression body syntax. So we have this equals mark after the function signature like this, and we just return the result of the if expression. But there is a thin line of getting too expressive with the syntax. So for instance, if we remove the explicit type specification from the function signature, it means that we are going into the land of type inference in Kotlin, and the type of the return type of the function will be derived from the expression, from the if expression. And if expression may have basically any type depending on the logic that you have in the branches. So if we remove the braces, we get this function like this. You remember we had like a long function with all kind of logic, and now we have just one expression. So it's concise, but is it readable? Let's think about it a little bit. If we cover the right hand side of the function like this, so what does the function return? We don't know. And we have to read the body of the function to actually be able to tell. And it's a source of bugs actually for many situations. If especially if it's an API, if it's a public API, then you should declare the return type, because by changing the logic of your if branches, you may accidentally trigger the different logic of type inference during the compilation, and as a result, the return type of the function will be different from the previous one, which means you have changed the public API. That's not a good situation to be in. For internal functions, for the private functions, that's totally acceptable, but not for the public APIs. So, but we can proceed further. So we learned about if expression, that is one expression. We have more of them. For instance, when expression. I like when expression because it covers more branches than just two. Otherwise, with if expression, you have to specify more conditions. And what else is very nice about when expression is that when you use it with Boolean types, enums, or sealed classes, then combine these two features creates sort of a safety net. So when expression will be checking the exhaustiveness of the checks. So if you checked all the possible types for this specific variable, then it will be okay. If some of the checks is missing, it will tell you that it's compilation error. You have to specify the else branch. So you need to add the remaining branches, either specify all the types or some of the types, and then the else branch as well. I know that in some projects the developers have this rule that they are not using this else branch for the when expressions to ensure that when you're adding another option of the sealed class, then all the code in such places should become red. So you need to make sure that you're actually adding a new handler for this type. That's interesting approach. I think it's pretty useful in many cases. So when expressions combined with seal classes is very safe kind of feature or idiom, we should say, because it consists of two features and they play well together. Let's talk about null safety. I think it's the unicorn feature of Kotlin. The other features are really great, but null safety is the one that I would personally use as an argument why I would like to switch to Kotlin, because it's a very, very useful one. Basically, null pointer exception is always the developer's fault. Like everything else can be like some logical fault or some environment fault, but null pointer exception is always the developer's fault. So if you didn't know about null safety, basically it's the feature of the compiler being able to check whether or not a value or a variable can contain a null, and then basically preventing you from calling something on that null, and thus preventing the null pointer exception. So you will get the feedback immediately in your code, and well, it's very useful. You get less null pointer exceptions. It's not a silver bullet. You still have to organize your code, especially if you are using Java libraries, because we cannot guarantee that Java library does not return null or anything like that. Or if you are working with some external sources like databases, HTTP requests, and so on. So you need to build a boundary of that null safe core internal in your application. But nevertheless, since once you have this boundary, you can be pretty sure that null pointer exception will not occur there. And but it's not enough just to provide a feature. You need to, like in language, you can have nullable types. You can have the compiler checks, but without tools to work with the nullable types, it's not fun. You need some efficient syntax to actually work with this feature. And let me show you an example. Probably not the best one, but it demonstrates the idea. So we retrieve the order, and we need some property in that order. The order itself is an object graph, so we need some property deep down in that object graph. So we need a customer, we access the address of the customer, and then we need a city. And well, in Java, I would express it like this. Even though it's a Kotlin syntax, it's basically the way you would do that in Java. And in Kotlin, with the safe call operator, we can get to that property, and with the Elvis operator, we can get the same semantics as we had previously. If we don't get the value that we need, we just throw the exception. So some people like to use the assertion, or not null assertion operator, but it's not a best practice. You better to avoid it. It's just the kind of a clutch or crutch, basically, in the language, so that, okay, I know that this value will not be null, then I'm fine if it throws an exception, basically calling for null pointer exception if the value is null. But in real life, it's better to avoid it. And the places where I see people using it is where they are relying on some lifecycle within a framework or a library. Like, for instance, in the tests, you have a field, and you know that this field will be initialized at some stage, and then you're pretty sure that when you're accessing this field, it will not be null, and then you're just starting to use this assertion operator. But actually, a more idiomatic way in Kotlin is to use late init operator, and then say that, okay, it will be initialized, but later on, I want to use a null safe type. So once it's initialized, the program is null safe. And we already mentioned the Elvis operator. That's another tool for working with nulls, or with null safety and nullability in Kotlin. And it can be used to form different idioms like this. So for instance, we are retrieving a person. We want to retrieve a value, but if this function returns a null, then we are fine with some default instance of that type. So we can check immediately using the Elvis operator. If the left-hand side, if the function returns null, then we just supply an empty person object. Or we can use the Elvis operator for the same null checks in our control flow. So I'm checking for the null here. If the name is null, and then I'm throwing the exception, or if the age is null, I'm just returning from the function. And using the Elvis operator, we can express the same. It will be just a little bit more concise. So if I replace if with the Elvis, it looks like this. It's practically the same, but the code became slightly more concise, maybe a little bit nicer. So this what makes this idiomatic use of the Elvis operator. Related to null safety, which seems to be not related at first glance, is the ability to cast the types, right? So there is a cast operator, which is an unsafe cast. It will throw the class cast exception if the type does not match. So other has this any type, and we want to cast it to the command type, and if it's not, it will throw an exception. But we have a safe cast operator with a question mark, as with the question mark, and basically if it doesn't succeed, it will return null. And we already know how to work with nulls. If we need to access some property, we can use the safe call operator and access the ID, for instance, here. Right? This is what also like a combination of different features in Kotlin that create this kind of idiom here. Ranges, another great feature, I think. So you can express ranges from one number to another one, and everything in between will be filled immediately. The values will be generated, and here is how it could be used. So we want to check if a character falls into the range of from A to Z. And this is how we could do that without ranges. We could just check whether or not the C is greater than A and smaller than Z. But we can convert it to a range check, and maybe it will be even more readable. So we can just almost express almost in English that C is in the range from A to Z without the math operators. That's nice. But some people would say that, hey, but it will create extra objects if I need to do this kind of checks all the time. Probably it will pollute my memory and so on. But actually, Kotlin compiler is pretty smart about this, and it will generate pretty much the same code, checking for the boundaries of the range as if you did that without the range operator. The ranges are comparable. They don't have to be numeric characters or character type. Then you can just create your custom types and make them comparable, and then you will be able to use ranges and range checks, even with custom types like this. So basically, you need to implement the comparable interface. Ranges can be used in loops, and this is probably the first, let's say, it's the most popular use case to use ranges within the loops. We can use the ranges within the loops, and we can use ranges to check if something falls into the range, right? Those are two major use cases. But for the loops, there are some interesting, situations, like whether or not the indexes are inclusive or exclusive. You never know. So, for instance, here we can say, okay, I want to run through all the elements of that array using the indices or using the until operator, so from 0 until the size of the args, and still there is no answer if until is inclusive or exclusive, right? You don't remember. You have to know about this. So let's run through indices. So we just iterate over all the elements. Why not? And there is another way to express the same, which is slightly safer. So we do have a range here, but the range is created, directly from the object, not you specifying from which element until which element you have to iterate. So that was a problem. And in IntelliJ IDEA last year, we created extra hints so that the editor would tell you, aha, the first index of your range is inclusive or not inclusive, and so on. But, well, it helps, but that's not all. In the new release of Kotlin, we have an experimental operator that we call range until, that would kind of, by its appearance, tell you how does the maximum element fall into the range, or it's excluded from the range. And you may play with it already. So if you download 1.720, you can check how it works and provide the feedback. It's experimental right now, but so far we had very good response from the community that it's useful, and I'm pretty sure it will stay in the language. Let's talk a little bit about the standard library. I'm thinking that I'm running out of time, but I really want to show you this example real quick. So I want to show you not just the feature here, but a task, an example of a real task that actually comes from Advent of Code from last year. And the task was, like, I'm trying to simplify it here. The task was that you get an input, a text input from the file, and you need to count the characters in the file in some way. There are rules how to calculate them or how to count them. Basically, you need to count all the characters that appear on all the lines. So if we have the input like this in the file, in the text file, we can see that D appears in every line for the first group of the strings, and X and Y appear on all the strings for the second group of the strings, meaning that D is the character we want to count, and X and Y also are the characters we want to count, totaling in 1 and 2, and the final result will be 3. That's the logic. How we can implement that in Kotlin? So imagine we have a file like this. It's a string, but imagine we are reading it from the file. And normally we would, split the input into the groups. So we have the first group and the second group. We can check it in the debugger. So it will be a list of strings. And then we need to split the strings themselves and see what characters are in those strings individually. So every group. And then we need to count like the same characters within each group of strings. Basically, we have to iterate over the strings within a single group and find the intersections between the sets of characters. And finally, we will get the total that we have to accumulate for every group. That's the straightforward implementation, basically like a baby code. But in Kotlin, we can do it a little bit better by using the standard library functions. And standard library functions will help us a lot here. And if you look at this code, we can see 2 parts, basically transforming data and calculating the result. So we can organize our code the same way. We can do some transformations and then calculate the result like this. So First of all, we can use the map function from the standard library to transform the input like this. So if you recall our initial example, we are iterating over groups, and iteration means calling the map function. We are going to invoke the operation on every element of the input. And then we need to kind of perform this operation. We need to transform every string into a set of characters. Finally, we get the same type as a result, a list of sets of characters. And then the calculation stage, like where we actually calculate and count how many like characters are there on the same line, we need to use this intersect operation. And then instead of actually calculating the total iteratively, we have this sum of function that will add up all the results, like all the results from the previous, like from the each intersect and count operation, and accumulate it as a result. So instead of iterating, we are using the sum of function. Then we like instead of iterating and calling the intersect function like iteratively, we just say that, hey, we need to call the intersect function for every element and accumulate the final result, basically calling the reduce function. And then finally we just call the count and get the result, like the final result. And it turns our like the code, our initial code that we had, into this kind of a transformation pipeline that looks very functional, I would say. It's probably harder to read from the beginning, but it's very expressive. It's terser, and here you would say that Kotlin actually promotes this functional style more. But in Java we do have streams as well, so it's not so different from Java. In this place, there are some other features in Kotlin that I'm not going to list today because I'm almost out of time, that actually show how well functional approach works with Kotlin. So this was the example. If you're interested in learning more details about this example, actually we have it all in our blog. You can find the videos with all the explanations and me and my colleagues live coding. But that's all the stuff I wanted to talk about. And well, I will take the opportunity to announce that Kotlin 1.7.20, I mentioned it already in the presentation, but we just announced it yesterday. It's a new release. It provides a few interesting features that are experimental, and I hope they will be stable in the next major release. So if you're interested, download and play and provide feedback. That will be really useful to the team. Otherwise, I'm happy if you learned something. If you have more questions to myself, then you can ask now or reach out to me in the social networks, and you can find the slides of the presentation at the speaker deck. So thank you for listening, and I'm happy to answer the questions, Marit, if there are any.
Thanks, Anton. Pasha has been very busy in the chat answering all of the questions about Kotlin so far.
Thank you, Pasha.
I really did love all of the discussions from people both new to Kotlin and more experienced, and people were also answering each other's questions. The last question was kind of interesting, even though people were answering already. Jason S. says, I do prefer the developer experience with Kotlin, but are there other benefits when trying to convince higher-ups to introduce a new programming language to the stack? Do you have any opinions on that?
Well, I think if I was the higher-up on the stack, who he would have to convince, for me, the safety features would be the primary ones. That's yes. One thing. And the other one is is not really technical. Can I make my developers happier? Can I attract more developers to come to my project? And so on. Can I reuse the knowledge of the technical knowledge within the team? So, for instance, if I have Android developers who are like 80% of them are Kotlin developers, can they actually share the knowledge with the new developers coming to the team? That's not a technical merit, but for me, it would be like an HR tool to actually,
Yes.
sustain my project with a headcount.
Yeah. So developer happiness is hard to translate into business value, but not finding developers will quickly translate into less business
Yes.
value. Yeah.
Yes.
Okay. Thanks for that. It was really interesting. Thanks so much for sharing all of your knowledge with us today. Do you have any final words you want to share with our audience?
Oh, I'm really happy to be here, and I'm really happy to see that so many discussions are there in the comments. That was the primary goal for my presentation, to actually spark the discussion. And
Perfect.
if this is happening, then it means that people are learning something, and this is what we are doing it for.
Yes. Thanks. All right. Thanks, Anton. It was nice to have you.
Thank you.